Hey, welcome back to Math with Patrick. Today is September 9th, and we're solving problem number 252 from the Daily Epsilon calendar. And we should show why the answer today is 9, because the answer should match today's date. So it looks like we're solving for x. X is the area of this rectangle. X should be 9, because that's today's date. And we have two circles. They seem tangent to each other, which just means that they touch at exactly one point. There is a right triangle that's formed right here. And it looks like the longer leg on that right triangle is a 3. And that's all we're given. So we'll see what we can do to answer this problem. Well, the first thing I'm noticing, I guess, like what math I could do with it anyways, is that I could just do some Pythagorean theorem stuff on this right triangle, right? Because a squared plus b squared equals c squared for any right triangle. And let's just call this, this 3 is going to be my a, because that's one of the legs. So I'll do 3 squared right here. And then instead of b, maybe I'll call this little r for like the small radius or the radius of the small circle. And so this could also be a little r, and this could also be a little r, all just because they're like the radii of this circle. So back to the Pythagorean theorem anyways, I have 3 squared plus r squared is equal to c squared, which is the hypotenuse. I guess the hypotenuse is formed by adding the little radius to, say, the big radius. So I'll use a capital R for the bigger circle. So little r plus big R is going to be the length of that hypotenuse. And so thinking back to the Pythagorean theorem, I should square it. There we go. So a squared plus b squared equals c squared. And maybe I could do a little bit of algebra stuff to this to like try to like combine like terms. So like this 3 squared is just 9. I'll keep the r squared alone. And then when you multiply this binomial by itself, you got to make sure that you distribute everything. I do like to use area models for these. Maybe not for like the binomial times binomial, but like it does help visualize all the multiplication that needs to happen. And it is a good strategy, especially when you start multiplying polynomials that are longer than just 2 terms. And here, this big R times little r and the little r times big R, both of those are going to be the same value, whatever the radii are. So I could do r squared plus 2rr plus r squared, and that's going to be all of the multiplication I need out of little r plus big R squared. And lastly, I see that there's an r squared on both sides, so I can simplify this to 9 is equal to 2rr plus r squared. Past this, though, I don't really see what I can do with it. I still have 2 variables, right? This larger radius and this smaller radius. And whenever you have like 2 variables in one equation, you could always just kind of like scale them a little bit. Like if I increase the value of big R, I think I'll have to decrease the value of little r, and I'm not going to be able to solve for either one. So a little bit stuck here. I think what might also be helpful to explore is like just trying to find some kind of expression that gives us the area of this rectangle. Fortunately, the sides, like we have some information about it, right? We have big R here and here for the larger radius, little r here and here for the smaller radius. And to find the area of the rectangle, all I need to do is this side times the other. So I could do r, so that's actually this one right here, r times, and then big R plus 2 times little r, because that's going to be big R is here and 2 times little r is right there. And that gives me the whole length of that left side. So this is going to be equal to x. And then if I expand this out, I get r squared plus 2 big R times little r. And what do you know? These expressions are exactly the same. This one right here is the same as that. And so I know that if 9 is equal to this expression, and this expression is equal to x, well then surely 9 is equal to x. And we're done. I don't know what the radii of the circles are, but I do know for sure that it doesn't matter. X is going to be 9. So I think what could happen with this problem is that we could actually like change the radii or the lengths of the radii of these circles. Like we could even make little r 0, I think, and we would just get a circle like this with maybe this length would be a 3. And then I think it would force this rectangle to actually just become a square. And it would just become like a 3 by 3 square. So I think this kind of built-in flexibility in the geometry diagram is showing up in our final answer, where we aren't really supposed to solve for big R and little r, because they are totally allowed to be slightly different values. Like there are rules, right? They have to satisfy this equation, but whatever values we get, we're always going to get 9 for the area of this rectangle. So there's my answer. X is 9. And we're all done. I'll see you tomorrow. Bye.